motor control. Before I will start our lesson for today, I would like to request to please subscribe or like our video so that you can follow. Okay? Please subscribe, then like our videos. Now, today, I will be giving you another type of connections. Still, the direct online magnetic starter. As what I have told you, there are different connections in magnetic starter. It depends on the application and the function. Today, I'm going to give you magnetic across the line or direct online magnetic starter with dynamic brake. Now, what is this dynamic brake? Usually, when you stop the motor is already disconnected from the source, but there is still an extra rotations. Okay? Extra rotation. Then, we want to eliminate that extra rotation because the application is needed for that particular, shall we say, connections, no? We need to have a dynamic or a quick stop. Quick stop. Now, there are two ways. There are two ways in connecting dynamic brake. By means of using a DC source. Remember, we have an AC source. But if you want to have a dynamic brake or a quick stop, then you need to apply the DC source. Okay? DC source. And we learn that AC is different from DC. So you need to review that. No? And then you can pick up that during your AC-DC machines or maybe in your basic electricity. I'm not going to give you that here. So there are two sources that we will be using here. The AC and the DC. Then there is also another way of stopping the motor quickly by using a plugging relay. Okay? Plugging relay. But I'm going only to give you the one type using a DC source. So there will be two sources that we will be using here. The alternating current and then the direct current for braking. Now, what is a typical example or where it is used? Now, the typical example is the elevator. Diba? So, if you want to go to second floor, you press the button number 2, and then you will observe upon reaching second floor, automatically the motor stops quickly. Now, try to imagine if you will not apply braking system in your starter, what will happen? So there's a possibility that maybe bulahos ka, no? Dili makatulong sa puntahan. So what is really important here is your controller. Then that is what we call magnetic braking. So again, this is a direct online magnetic starter, no, with dynamic braking. So I'm going to place it there, dynamic braking, or a quick stop. Okay, here, quick stop. So direct online magnetic starter with dynamic braking, quick stop. Now, this time, you will still use contactors, diba? You will still use contactors, but this time you are going to use two contactors. Then these contactors are AC contactor. Remember, these are AC contactor. So the power circuit now is different from the previous one. So we have here the power circuit. Okay? We have here the power circuit. Okay. So here is the power circuit. You have here the brake contactor, and you have your main contactor. So that is why we place a B and M to identify the two contactors. Again, these two contactors are AC contactors. AC contactors. Meaning to say the holding coil is really intended for AC source. Then you will have here considering that this is DC, as what I have told you that we will be using two sources, AC-DC. So since this is DC, so we need to identify the positive and the negative. Okay? Positive and the negative. You have here. Then of course, the voltage here will not be more than 220. Why? Because you will only press the button for a short period of time. So when the motor is already stopped, then you release your finger immediately from the push button. Then your source is 220 AC. So if this is a three-phase motor, you just simply connect the brake contactor parallel to line 1 and line 2. Meaning to say, you are just simply energizing one phase of the three-phase motor. So energizing the one phase using DC contactor is enough to stop the motor quickly. So if you don't want line 1 and line 2, you can have the line 1 and line 3. Or if not, the line 2 and line 3. Okay? So there are only two lines that you need to energize using a DC source if you want to stop it. Okay? You have here, so if that is single phase, of course, you condemn one line here, and then you connect the brake parallel to the AC. Now, you have here the condition. So, while the motor is stand still, you're not using it. Operation, you have what contactor that will close and what are the contactors that will open. So, when still it is in the off position, the main contactor and the brake contactor are open. Then, when you start the motor, of course, the main contactor will close and the brake contactor is still open. Then, you want to stop it quickly using what? Your double contact or a brake make push button. So, what you will do? You just simply press the button stop. So, when you press the button stop, the main contact, or rather the main contactor will be open, and then it is now the brake contactor that will close. So when the brake contactor is closed, then automatically, so this will close, automatically the DC will energize one phase of your three-phase indoor motor. Okay? So this will energize line 1 and line 2. Then the motor stop quickly. So when the motor already stopped, immediately release your finger. Now why? Because if you will not release, and then the motor is not running, then still the DC or the direct current is still flowing in the in the windings. So a tendency that your winding becomes hot. No? So to prevent this, press the button stop. Motor stops quickly, then immediately release your finger. Okay, that is the precaution, so that you can protect your motor. So don't ever forget the power circuit and the control circuit. Now, how would you connect it? Okay, how would you connect it? Meaning to say, what would be the control circuit? Oh, you have here the control circuit. I will draw the control circuit. Okay, it is like this, so that you can follow. Now, I will draw the control circuit of your dynamic braking. Okay? So again, you have your overload contact. Then, you have your, this time, you will be using a double contact or a brake make push button for your stop. Okay? So you are using brake make push button or double contact. Then you have your start button. So this is your start button. Okay. Then of course, you have your magnetic coil. Then you have your what? Your maintaining contact. Now the maintaining contact is coming from main contact. So this is your main contact. Okay? Now, how about the control circuit? I mean the dynamic brake. Okay? So we have here M. You have this, no? So you have your M, this maintaining contact is taken from main contactor. Then you will place jumper here. Then you have your brake contactor. Like that. So this is your brake contactor. That one. No? So when I press the button, start, this will energize. So in the power circuit, immediately the alternating current source will energize the motor. So the motor runs. Okay? Now, while the motor is running, then I want to off or stop the motor. So I will press the stop button. So when the contact is still in the middle between the two contacts, so what will happen to the M? The M now is de-energized or what? Already out from the circuit or disconnected from the circuit. Then press it, it will touch here. The contact here will touch, will contact this portion. Then the brake now is energized. Now remember, this is an AC contactor. And then try to review the power circuit. So when the brake contactor is energized, so what will happen to the DC? So the DC now will be the one to flow in one phase of your motor or energizing the motor. Okay? Now the purpose of that is to stop the motor quickly. So when you off or remove the AC source from the main, still the motor stops. Actually, the motor is disconnected, but there is still an extra rotation. So the DC now is the one responsible to stop that extra rotation. So when the DC source or direct current will energize the windings of one phase of your three-phase motor, then of course the rotor there will be magnetized. Okay, will be magnetized. Then the motor stop quickly. Okay, so that is the principal operation of the dynamic brake. But take note, no, this is a precaution. When the AC source is still in the circuit, before you will switch on the brake, no, see to it that the AC source is already disconnected. That's the time that the DC will come in to your motor. Because if the AC is still there, and then the DC will immediately energize, then what will happen? AC and DC will not be mixed. So that will energize the load one at a time. So in order to prevent this to happen, you need to place here an interlock. Okay? So this is what we call interlock. So interlock now is responsible to prevent the AC and DC energizing the motor at the same time. So this one you have here normally closed. This normally closed is taken from the brake contactor, while this one is taken from the M contactor. So look at this. So when you energize, when you switch on this one, of course, what will happen to the M contactor? Energize, right? So when this is energized, what will happen to this? This will open. So there is no tendency that the DC, review your power circuit, while the AC is there in the motor, the DC will not. Why? Because the contactor, brake contactor is still open. You have your interlock here. So you need to off the main so that this will go back to normal position. So there is, when you off the main, there is an extra rotation. Then that's the time that you will press the button stop back. Then what will happen to this? Energize. So what will happen to the contact above your interlock? Will also open, considering that the brake contactor is energized. So there is no possibility that the M where the AC is flowing. So when it is de-energized, only the DC comes in or energizing the one phase of your three-phase motor. So that is safe. So you need to place an interlock between the M and the brake contactor. Okay? So that is to prevent damage. So that is what we call, this is the control circuit of your, what? Of your magnetic across the line, direct online magnetic starter with dynamic braking or quick stop. We are going to use what? Two sources of electricity, the AC and the DC. What's the purpose of the AC? To run the motor normally. What's the purpose of the DC? To stop the motor quickly. So I hope you understand. Okay? Now, don't even forget, no? The DC will not exceed the 220 volt AC. Kamay mo, 1/2 lang. 110 is enough. Anyway, the DC will energize the one phase for a short period of time. So maybe 1 second or 2 seconds, enough to stop the motor quickly. So, again, it is nice to connect that in actual so that you can really observe. No, you can really observe. But don't worry. Don't worry. Because I'm going to connect all, most of the diagrams that I presented to you, I will connect it. No? So, just review. I will connect it, like for instance, 2 stations. I will connect 2 stations to let you see the actual operation. So, when it is jog, I will connect jog for you to see the actual operation, including the DC. Now, in fact, it is really a problem when it comes to three-phase motor because I don't have three-phase source here in my home, no? It is only single-phase, considering that this is only residential wiring. But you don't need to worry because I'm going to have a VFD, no, variable frequency inverter or drive. So the source is single-phase, but the load side is three-phase. So we can run a motor, though our source here is single-phase, by using the variable frequency drive, the BFD. So we have that. No, I will bring that one. In fact, I will also introduce that BFD so that you will know. So the BFD that is available in our laboratory, I think that is 12 kilowatts. So dako, no? So we can run a motor here that we have a motor here 1/2. So it is okay for that BFD. So even three-phase, I will demonstrate it to you. The forward reverse for three-phase, I can demonstrate because of that BFD. That will be our three-phase source. Okay? So again, thank you very much. Watch out for more connections in full voltage magnetic starter. Then after having the full voltage, of course, I'm going to proceed to what? Reduce voltage magnetic starter. Then usually, I will only demonstrate to you here the control circuit. But I can illustrate to you the power circuit. But in demonstration, I will only demonstrate to you the control circuit. Because there are 4 types of reduced voltage magnetizer. This is very important. Then after having that reduced voltage, then we will go to sequential control. Okay? Sequential control. So maybe we can touch a little topic on conveyor, no, where you will use the sequential control. And mind you also, in giving the exam, no, you know that is an issue today because there are some instructor that they will really give examination. Of course, this is to gauge your learning. But for me, it's different. I will only give you problems. No, I will give you problems then by group. So one group, you solve this one, another group will solve this one, so on and so forth. Because, you know, according to them, they try to solve. There will be no cheating. But we cannot avoid that, considering that you are at home. So it is very easy for you to contact your classmate and then you ask the answer. Diba? So we don't mind that. It's up to you. But in my case, I will give you problems. So you will really solve the problem. So let us see, in one group you have 5 members. Then you will use the Zoom. Then from there, maybe individually, you try to solve the problem, all of you in the group, and then use the Zoom. Then you discuss. You present one by one. Then try to discuss so that you can come up the correct diagram or the answer for that particular problem. So you know, if you are in the industrial plant, if there is a problem, the supervisor, the foreman will call all the technicians, electrical, under the electrical department, and then they will be having a brainstorm to solve that particular problem. Then from this kind of method, then at least you are already practicing brainstorming. Remember, when we say brainstorming, everything is correct there because that is your own. But you have to come up a better answer or better idea. So while you are in group, you try to interact, you participate, meaning to say you apply the technology of participation. Because while you are discussing the problem, it seems that you are having the what we call, I will borrow the term used by my colleague before, intramurals of ideas. So when we say intramural of ideas, your idea is competing, and there will be one that will come out winner. So you consolidate your idea, everything, then there you are. You can have the solution of that particular problem. So that is what we call a collaboration of ideas. Okay? That is brainstorming. So you better participate. So hopefully that the pandemic will, you know, begun, then we will have our actual connection in our laboratory. But mind you, guys, if we are done with this semester, and then you are not, you know, even once, you are not able to connect the actual, maybe in the second sem, and then the pandemic is gone, then we are already allowed to go to our laboratory. Even, I am no longer your instructor, but if you want to connect all those diagrams that we have here, you are free to go to our electrical laboratory and then connect all those connections. We will allow you that. Okay? So I hope it will encourage you. Okay? So you can view our videos anytime you want. So that's all for today. And don't forget to like our videos and subscribe. Thank you. And again, God bless us all.